as you guys are signing in, I think we're gonna just go ahead and introduce the agenda and what we're gonna do here today. And I'm gonna hand it off to James to get that started.
Okay. Do you want to share the slides?
Sure. Okay. I'll do
Thanks.
that.
And we
Yes.
can just go right to that first one here. Um, so agenda. Um, First of all, we're going to go through an introduction, goals and approach. The overall intent of this is to bring together a group of people who will work over about a 6-month period to develop a content metadata standard for chunks, or for the chunk manifest, as it were. And so we're going to do this by splitting up into breakout groups and talk about a couple of things. Talk about what are chunks and why a standard might be necessary. And then we're going to bring those things back and sort of synthesize them and put them together. And then we're going to have another breakout session, probably the same groups, where we talk about a couple of different existing chunk manifest implementations and think about how their features overlap and what differences exist in those. And then we're going to get together and we'll sort of synthesize those things and then go on to say, okay, so where do we go from here? What sort of steps do we need to take to really push this idea forward? Um, so our facilitators, our breakout leads, Alexander Jelinek, he has experience, he's from the HDF group, and he has experience with Gerchunk and also the HDF4 file content mapper, which is one of the very earliest attempts to create an external metadata representation of the chunks in a data set. Max Jones is here from Development Seed. He has a lot of experience at Czar, and all of these people have experience in many other things, but we're just going with the short answers now. And then Luis Lopez has experience with Kerchunk and virtually Czar. Ed Armstrong, standards compliance. Myself and Miguel Jimenez have experience with DMR++. And the facilitators are myself, Arika, who's been speaking already, and also Miguel. And then Mark Parsons and Maddie Berger are the ESIP representative and tech folks. So, um, any questions so far? All right, well, hearing none, and since time is short and I've been told to be brief, which it's hard for me to do, I just want to say a few words about what a content metadata standard is. And partly, I should probably warn you all that I'm not really an expert in standards or metadata. Okay, so these definitions may not be exactly what Wikipedia tells you, but standards to me are something that is used as a component in a design. So a person is developing a system and they want to create that design that uses proven predictable characteristics. This is different from the way a lot of people think about standards. They say standards facilitate interoperability. They certainly can, but one of the things that they help implementers do is they help them learn from the experience of others. They say these are the things that worked, and sort of by inference, they sort of say what didn't work as well. And that can certainly promote interoperability. So metadata, literally, right, data about data, but that's not a terribly useful. That's not a terribly useful definition. Metadata can be thought of as either descriptive, administrative, structural, or markup descriptions of information. And in this group, our focus is likely to be mostly administrative and technical and structural. So that kind of initially runs at cross purposes with the notion of a content standard. Content standards are like guidelines that dictate how textual values and metadata should be structured. That's a quote from this document from NISO about understanding metadata. So usually content standards don't include administrative or technical metadata. But I think that for us, it's going to look like it's very technical information, but what we want to do is focus on the content um, and some implementation details, but primarily not actually implementation details. So, um, so we don't want to worry about, for example, whether it's XML or JSON. That's not really what we're interested in. What we're interested in are more how the building blocks are put together. Um, and then, so what are our goals? Well, the first one is we want to differentiate between these existing chunk manifest implementations. So, what's common between them? What concepts do they have in common? What are their differences? Where has one gone that the others have not gone, essentially? What sort of problems has, say, Kerchunk tried to solve that DMR++ has ignored? What sort of problems has Czar tried to solve that Kerchunk has ignored? And then the other thing that we want to do, besides noting the commons and the differences, are can we develop a draft standard document? And from this, um, we will provide this kind of description of what exists, nominally warts and all, and do so within about a 6-month time frame. And so we're going to need to think about what kind of structure as a group is best. Generally speaking, standards documents are hard to come up with, but we don't need to come up with a true standard. We merely need a draft document here. So some sort of comprehensive description of these things, but it does not have to solve problems. In fact, one of the statements we made earlier was we're really brainstorming at this level almost. And we're not trying to solve problems. We're not trying to fix a deficiency in one of these implementations, or even maybe its underlying design. That's definitely the case. So that's my introduction. Um, are we ready to start the breakouts? The initial set of breakouts? Do you want to explain a little bit about that, Erika?
Sure, yes. So in this session, this is interactive. So we're gonna make you guys talk to each other. We are gonna have a couple series of breakout groups, and then Mark, I'm speaking slowly to give Mark a little bit of time to set them up. We're gonna have each of the facilitators be leading one breakout group. And because there's quite a few people, which we're very pleased to see, we're going to just kind of randomly sort you guys out, and then with one facilitator leading each one. And then when we're going to have these two questions: what is a chunk manifest, and why is a content metadata standard needed? You're going to have about 10-15 minutes to talk about that. Let me double check. You'll have 10 minutes to talk about it, and you're going to write down in one of these, just one of these little notepads here on the Google Slides what you guys are talking about. So whoever wants, this is everybody pitch in type of session. So if you want to write, go for it. If you don't write, your facilitator will make sure things get written down. Welcome back, everybody. Hope you guys got to meet each other if you didn't know each other already, and have some good discussions. We were watching the stuff, kind of the slides fill in. So thank you all for adding. Feel free to keep adding to them. I want to give you guys, everybody, just take a couple minutes to just browse through. This is called a gallery walk. So you can just go through and see what other groups wrote. And while you're doing that, consider, what do you see there that surprised you? And what do you see there that you expected to see? And then also, what kind of questions do you have? And these are all questions that I put on slide 20. And in a minute, I'm going to ask you guys to speak up, or even just share in the chat as you feel like it, what some of the answers to those questions.
A couple of the things that I see that really interest me are the words map. It's very interesting, but as far as I know, one of the earliest attempts to take this kind of meta information about the structure of data and make a formal external document that describes it started as something called H4 Mapper. At least I think that's what it was called. And that was begun by Ruth Dewar and Kent Yang. Um, and that was quite a while ago. And what they were actually thinking of, just a bit of historical context, is they were thinking of how would you read data from these HDF4 files if you was 50 years in the future or 100 years in the future and the API library didn't exist or didn't run anymore. And it's a pretty interesting problem, and it's probably not one that we should ignore entirely, although it's pretty laudable that they attempted to do that. So, but the other things, so we see the word map, and also I saw URL, and I saw offset, and I saw bytes, and those are all things that we're working with in these chunks, right? ZAR references things by URLs. When we work in Earth Data Cloud and the NASA scope, we think about URLs to a service that goes and fetches these things. So, right, so all those things are true. Um, in our group, I'll just talk about our group for just a brief moment. One of the ideas that Amy brought up was that we think about all of these different pieces of information, like the encoding of a chunk, but we don't really, but we need to be, we want to be explicit in where we pin that information. We probably want to put that information as high in the stack as we can to avoid replication, because that replication makes these manifest documents very, very large. So, like, pin that information to the variable, not the chunk, when it's common to every chunk that comprises that makes up a variable. Um, I think we had a lot of other things going on here. That compression information um, certainly applies to chunks, compression and other encoding, but generally those encodings are homogeneous for a particular variable. And I think one thing that we didn't note in our breakout session was that oftentimes there is an assumed model here that the data are built up of variables, and those variables have things like names and data types. And that is not part of the chunk manifest per se, but it's an assumption, but it's an underlying assumption in the chunk manifest concepts that at least I'm familiar with. So I think I should stop talking because I will just go on, and whoever led group two should share their information.
Hey, hello. This is Group Two at Armstrong, and what's written here, I think it's a little bit discombobulated, but it's kind of short and brief. I think, yeah. Again, when we're thinking about what is a chunk manifest, it's in our mind, it's the representation of the variables, the bytes, the byte length, the byte offsets, and any other related information with regards to compression and metadata that software needs to understand and read that chunk and use it. Um, and so, why is the content metadata standard needed? Of course, I think one of the big things is that if we have a standard, it'll improve computational efficiency in using these chunks across different libraries and different software libraries that access and use these. We got a little bit into the weeds, I think, and maybe put some things. We suggested maybe that the chunk manifest would is important for describing things like data provenance and granular discovery. Maybe that's a little bit in the weeds there. We didn't really kind of formulate those ideas, I guess, too concisely, but maybe we'll just keep them on there for right now, and maybe we'll have like further discussion on those topics. But yeah, certainly, having the chunk tagged with some appropriate provenance of where the data came from, as we're kind of virtualizing these data sets, I think will be important for applications to use them downstream. Okay, that's us, group two. Thank you.
So we probably won't have time to go through all the groups just to keep us on track, but I think we can hear one more group, and then the next breakout session, we'll probably hear from the other facilitators. Is there one more group that wants to share?
Of course, I'm group three, so I would say after group two comes group three. Um, but no, I want just briefly, and then other groups can talk. What really came out from our group that I really think is the most important fundamental question is what chunk manifest content should be. In other words, we discussed two ends of the scale. One is essentially just chunk information, how to get them, and anything just needed to understand the bytes in those chunks and to read those bytes from the chunks, nothing else. And on the other side of the spectrum was, well, all the entire other content that that container holding a chunk might have, so that you never ever again need to go back for any other information regarding that container. So we kind of thought that there's kind of a dial here that you know how much you want to go extremely one way or extremely the other way. So that's it.
All right, we actually have room. We have time for one more if the next group wants to share.
Yeah, group 4 comes after group 3. So we went over some definitions of what chunk would be, chunk manifest, and from there dove into some more like granular definitions about a chunk, and why these concepts are valuable for users operating at different levels of the stack. And then I gave our group a lot of leeway in how we interpreted the second question. And from there, we also pretty immediately dove into what would be needed in a content metadata standard of the chunk manifest in order for it to be useful, I think in a similar way to Alexander's group. And then we abruptly got cut off as Jarrett was about to, I think, drop some amazing wisdom. So I think, yeah, there's these conversations. It seems like there's appetite for them to keep going.
Great. All right. Well, Miguel, and let's see, and Louise, we'll get you the next. We'll get you the next round. And then everybody else, yeah, if anybody has it, just things that you're thinking about, you want to put in the chat, please feel free to do that. I think a lot of this, this session is about us just brainstorming and thinking and start seeding these conversations. So on slide 21, I'm not going to share my screen because apparently I just start browsing around, but what we'd like to do here on slide 21, and I think we can all do it together. Maybe this won't take that long, but this is like, we're basically trying to brainstorm here and just free list. What are the chunk manifests that are out there? Do you guys know of one that we don't have on our radar yet? And please feel free to write in the ones we know. Or call them out and I'll write them.
So
This is so annoying.
a
Okay.
question for this for me is, are we considering the like HDF5? Like, because it has a chunk manifest inside of it, right? So does GeoTIFF.
Yes.
In many ways, I think we probably should consider them, definitely. Although for the HDF5, having initially hacked into the HDF5 library before it externalized the chunk stuff, I can say that it's very, very complicated. Its chunk manifest is very complicated. So, but yeah, we definitely want to include those things. Ice chunk, that's another sort of obvious one. One of the things that might be a dividing line, though, between these things is that HDF5 does not it does not contain a sort of an explicit document. Actually, this is a really sort of a fuzzy thing, but it never really intended to move its chunk manifest from one place to another and say, oh, here's a thing, go use it. Whereas all of these other things up top, it keeps on switching for me. All these other things up top, they have explicitly said, yeah, we're going to make these things out there and explicit for you. So, but yeah, I think
Sorry if I can just say a little bit. There's a really interesting question in the chat by Amy about NCML. I know a little bit about NCML, but I think maybe even Sean or James, are these do they, like an NCML, do they contain chunk mappings? Because in many ways, an NCML file, it is kind of like a virtual representation of a collection aggregation, but I don't know if it has chunk mappings, and I think that might be the difference. Anybody of you both or anybody else want to chime in?
NCML won't describe the chunk mappings. Yeah, it does expose the special attributes about chunk sizes, but it won't talk about chunk mappings.
Thanks, Miguel, and thanks for your response. I think that's a good actually clarification then of like what a mapping isn't, chunk manifest isn't.
Do we have any other thoughts on other chunk manifests? I see some people still writing in there. We do have a few more minutes to do this exercise if anyone else also wants to just speak up.
I I put a question in the chat about are constraining this conversation to array data because I've dug recently a lot into the Parquet format at a low level, and I think there's a lot to learn from that tabular side of things about how to organize chunks and heterogeneous chunk accommodation and statistics and all sorts of things that I think would be very applicable on for array data as well.
That's really interesting, and I think at the risk of like falling into some sort of weird feature creep, I think we should at least initially include it. Definitely. It's a point of ignorance on my part that I know next to nothing about Parquet. It's a great flooring, but as a data structure, I don't know. So let's definitely talk about it, especially if it deals with chunk heterogeneity, because that's a tough one to deal with when there's lots of them. Um, so yeah.
So maybe a dumb question from me, but why is tabular data different than a 2D array? Like, isn't a table just a 2D array?
Well, it from like in one point of view, no, there's no difference, right? Like an array in Lisp, every cell could have a different type, but generally, in my mind, anyways, arrays are by definition homogeneous with
Okay,
respect
yeah,
to
that's
the
a
type
good.
of the element.
I would just say in tables, the rows have no connection among each other. There is no relations whatsoever that row one and row two and row three means something being row one, row two, row three.
Yeah,
In
that's
array
all.
storage, the array elements being adjacent to each other actually carries certain fundamental meaning why they're next to each other. Like in an image, if you want to represent image as a table and image as an array, it's two different ways how you look, you know. So I think that's the difference. Adjacency of array elements actually has some fundamental property meaning.
I think on disk, though, you have to linearize either of them. So if you have a multi-dimensional data set, whether it's tabular or array, the concept is the same. You have a hypercubic space that's projected down into one dimension in some way to be stored in memory or on disk. So
Right.
I think at that level, to me, they're both the same problem. It's just that tables tend to be sparse within that space and arrays tend to be dense.
Okay.
I was just going to mention that that's kind of sounds interesting in terms of, for instance, unstructured grids, which are often stored in SCDF, HDF, and they have
Right.
a very different structure. They're not, you have to actually explicitly define the connections between the different points, but they are stored as arrays and are often chunked data. So it's, I don't know, there's a lot there to unpack, I guess.
Yeah, I was thinking about that as well. We thought about subsetting swath data and representing the result as a table in latitude, longitude, and measured parameter, in in a sort of a simplistic sense. And so then you could imagine that also as a vector of structure elements. Um, Unfortunately, things like structures are pretty hard to work with the usual way that we are dealing with chunks now. Although possible, but not easy.
I'd add one more point. I think we tend on the array side, if you have a spatial array, to tend to consider querying, you're looking for something within these coordinate dimensions and don't consider the data variables. But in reality, an analysis is I'm only interested in the chunks within the space that have data within these ranges or something of that nature, which is very similar to how you would query tabular data as well. You've got
Yeah.
filters that you're trying to apply to other non-spatial dimensions, if you will.
Uh-huh.
So there's a lot to be learned from Parquet in that sense around how it accommodates predicate pushdown to the file storage layer that could be applied to array data beyond just coordinate dimensions.
Mhm.
We have time for one more comment. If anyone else or question, if anyone has any. All right. Well, we've got quite a list here. There's 11 if I counted them, unless someone added one here. And all right. So then for our next, what we're going to do next is if you look at slide 22, we're going to have another round of breakout groups. They're all going to be led by a facilitator, just like the last ones. And their questions here are, how do these chunk manifest approaches overlap and how are they different? We have 11. So what we were hoping to do, if you look at the slides from 23, like slide 23, for example, there is we have a Venn diagram. So what we'd like to do here is give you guys a chance to really discuss by comparing a couple of them. And I'll just give you a really quick little, I'll share my screen at this time. But so basically what you're gonna do is you're gonna write whatever approach you wanna investigate. We're kind of hoping people will do different pairs, but we won't like try to social engineer that. So just kind of try to see if you can pick two that seem different than what other groups are doing or whatever it is you have the expertise in your group to do. You can replace this name here with a name like czar, for example. You can put a name here as well. You want to compare, say, Kerchunk. And then what you'll do is you'll write whatever note you want to write, and then you're going to move it over into the space it belongs to in the Venn diagram. And your facilitator will help you do that. We'll have 15 minutes to do this, and then we'll come back and chat about it. All right, there's lots of notes here to review. Again, like we did last time, if you guys want to just take a minute to browse through what folks wrote. If you've also got some last minute notes you want to take on your slide, you can do that too. And while you're looking through this and reading through them, you can think about things that you found surprising. Were there things that you expected to see that maybe you didn't see, or maybe you did see them there? And then also, what questions do you have? And whenever you're ready, I mean, anyone can speak up as well, but if we want to just get the conversation started, maybe Louise, do you want to
Sure.
share first?
So we spent a little bit of time in the Parquet side of things. Like we were talking about the characteristics that make Parquet a good file format for the cloud, that it's columnar oriented, and the hierarchies. Some of the strengths of the Parquet format, more than if we can see it as a chunk manifest, it's not a chunk manifest, but as a file format, it has some characteristics that could help shape this chunk manifest idea. For example, that one thing that I didn't know is that it can have heterogeneous like compression algorithms. So it's not like a one algorithm for the whole data set. You can have different pages with different compressions depending on what's in the data. And a powerful thing that Parquet has is the metadata statistics on each of these chunks. You have like a summary of what is in the chunk. So, you know, if we're talking about temperatures, it will have like in this 1 million rows of temperatures, it will have the mean value, the max value, the standard value. So when you read the metadata, you know what to expect. If you're filtering by certain things, it will be very easily to discard or include data based on those statistics alone from the metadata headers in Parquet. And then we talk a little bit about Kerchunk and like what is Kerchunk. We didn't have a lot of time to talk about Kerchunk, but we got to the core of it, which is like, you know, pointers to data files and things that are similar, like we can serialize Kerchunk in Parquet. and that kind of thing. So we did that.
Thanks, Louise. And Miguel, do you want to share?
Yeah. So we were group three, and we spent some time trying to figure out where kind of like the overlap was between our expertise and I'm going to say something, and please, everybody in group three, please feel free to chime in after I'm done. So essentially, we figured out that we were going to talk about ZAR v2 and DMR++. I think that was kind of like the dominating sort of interest and domain of expertise a little bit on that side. And so that was actually a really interesting question by our facilitator, like Maddie, in terms of the idea that is ZAR v2 a file, like a chunk manifest, or how does that, is like the versioning with the idea of versioning in terms of like v2 versus v3. I know more about v2, so we focus on v2, but the idea of versioning in terms of metadata references was interesting. The fact that ZAR is also a file format, or you can think of it as a file format, not just a chunk manifest. But yeah, so we focus on this idea that DMR++ is human readable, if you could say both of them, sorry, human readable, but with a DMR++ is XML. And it contains within a single XML a lot of the maps of the individual chunks that are positioned within a file and without breaking apart the file. So that's contrast with the idea of SAR-v2, in which all of the chunks are exposed, individually exposed or labeled in a sequential order. And you have metadata in JSON file as opposed to XML or just JSON, which also can consider to be human readable. And which tells the internal API of like essentially what the chunk sizes are to be expected and how to read or like find these chunks as you're trying to say subset a data set. We talked about a little bit into the details of compression, like something, for example, like BLOSK that is probably not supported fully within DMR++, but it's widely used within SAR-v2, and maybe I'm wrong with this, but that's my impression. And then both of them kind of contain like bytes offsets and some like chunk position in an array. Yeah, I think that was mostly it. And if anybody in group three wants to add something for the summary that I just gave, please feel free to do so. If time went really fast, so I feel like we could have needed. I feel like all of us, all the different groups, we could have a little bit more time to discuss. But yeah. So I don't hear anybody from group three from the group. Okay, so that's roughly the summary. It went really fast. And maybe we should talk about a different group. It's very interesting, different groups as well.
There are any general comments based on what Louise and Miguel said?
There was a question for Louise. I just want to flag in the chat from Chris.
Yeah, I think that's an interesting proposition. Like if Parquet supports this, heterogeneous compression filters in different shards of the files, well, the Parquet reader knows how to handle that. But at the moment, the SAR model and the SAR driver, there are checks to like ensure that the compression is homogeneous or the filters are homogeneous, because I'm guessing it does some parallelization and does like it uncompresses the data in a way that it knows that all the filters are the same, so it doesn't have to hot swap the compression filters and all of that. So I'm guessing that for this to work in a chunk manifest, the client will have to take these things into. And I think the SAR community is working towards like supporting these things like variable length, variable compressions, but I don't know. Max will know more about like what's the state of things there.
Yeah, definitely working on variable length. Variable compression is something that there's an open issue on, and there's not currently a champion pushing that forward. So if anyone's has some cycles to spare, I'd be happy to set you up with a really important issue to work on.
I had a quick question about that. I assume that you're talking about the Python, ZAR Python as the implementation for Python, for ZAR, all these features and support. And I guess I'm wondering if there's similar, or if anybody knows of the other implementations of ZAR, what they support, if they support these variations. And I guess I had the same question about Parquet. I know it's like a standard and there's software, but are there multiple implementations of that?
I can take a stab at both. For Azar, I would say that the Rust implementation and one of the C implementations, which is in TensorStore, are actually faster at prototyping new extensions and standards than the Azar Python library because they are newer, and so they have less backwards compatibilities that to like consider in how they design new features. So the short answer there is yes. And as for whether there are multiple implementations of Parquet readers and writers, absolutely, there's a lot.
Now, there is one thing that I'm not sure if we cover, which is like the power of Parquet is that it's a columnar-oriented data format. It doesn't fit all the use cases for remote sensing data necessarily. So that's why, well, it seems like the best thing to do, but if we like compare use cases, like there is a reason why rasters are not serialized in Parquet. So, or maybe not. That's what we're talking about.
So I'm going to ask Ed to share next because it looks like you your group compared a couple of different approaches.
Yeah, okay. So we had like a little different animal. We looked at for chunk and versus grib, and so thanks to Sean Arms, we elected to look at grib. And so yeah, there are certainly some commonalities and certainly some significant diverges into how these two technologies implement chunk manifests. So the commonalities, include things like that both manifests include the byte ranges, of course, and that they're external files persisted to disk, and they use similar num codes, compressions, schemes. Those are commonalities, but certainly some of the differences. Grib is really a different animal, and it externalizes a lot of things. For example, the compression is contained in a table that's manually curated, right? So that's certainly a different. And really, it's a specification that is very tightly controlled and implementation independent. That's what we wrote. And there are, in fact, unfortunately, very few examples now of grid implementations. Maybe just because the community is smaller, but certainly that's something that differs from things like virtually ZAR and Kerchunk. So with a virtually ZAR and Kerchunk, the metadata adheres to ZAR standards and specifications, and of course very tightly coupled with Python, as we know. So, but yeah, I didn't know too much about how Grib does things in the world of chunking and chunk manifests. So it was a kind of a learning experience for me, and yeah, something that we consider as we're thinking about developing future standards. How to wrap things like Kerchunk in that type of activity would be something I think we should give some thought to. So, any questions for our group? And hopefully I represented everything correctly, but if, Sean, if you want to speak up, maybe add a few things, or feel free to do that.
I think the one thing I would highlight is that when we look at a chunk manifest for Grib, the data set schema is not really there. As someone who's consuming that manifest, you have to reconstruct what are the variables or dimensions or whatever data model you're trying to get this random collection of messages into. And I think having parts of that be implicit in some of the standards that are out there represents a risk if it's not well defined and explicit in the manifest itself. There's individual components of the data set at a data model level. Grib really doesn't have that.
Yeah, thanks for pointing that out.
All right, we've got a couple minutes left. So, and before we're going to go into thinking about what our next might be. Does anyone else have any comments? Or maybe we can do one more share out. Alexander, since we haven't heard from you, do you want to share quickly?
My group was kind of a teaching group. We enjoyed, there are quite a few happy users of what's currently being done, for example. So, but we covered Kerchunky and DMR++. There were mentioned some other interesting chunk manifest opportunities, but none of us had any direct opportunity, experience with them. So we kind of stayed away from those. And basically, we looked at Kerchunky and DMR++, and we agree that obviously they both provide the main important reason for chunk manifest in their own ways. Kerchunky is obviously right now contribute to the ZAR ecosystem or ZAR-based software, because Kerchunk just records chunk locations there where they come from, the files, and where in the file a specific chunk is. Everything else, compression of those chunks, and it's expressed as ZAR internal metadata. Whereas DMR++, as people know, are tied to Hyrex web server. And then I don't want to go through. People know about Kerchunks and DMR++, so I don't think that all of this information is something new. So I will just stop here.
Wonderful, thank you. All right, well, James, I think you're up if you want to lead our little discussion here. We've got 15 minutes at the end of the sessions. We'll like to use this time to look at the last slide, slide 30.
All right. Yeah, so next steps. Oh, I'm not muted. Great. Okay. So one of the things is that in tomorrow's ESIP, there is a session, Bridging the Cloud Divide, which Amy is leading. She has two 90-minute slots. And we are going to report our information at the very end of the first of those 90-minute slots. So Miguel, you volunteered for that task. And my initial take is that if you go down the 6 slides and you look at the stuff in sort of the center column, which is the common, although I noticed there's a couple of questions on group 6 ones, like can manifest be created, and so on and so forth. So we might have to resolve those. But there's a lot of common information here. And so that's one thing to report for sure. Okay, and then there's other things. And there's also enabling standards compliance in Wednesday afternoon. So this is a thing that I came across when we were talking about API design like decades ago. You can design an API and it can be really awesome and it would be really wonderful if that was actually implemented, but nobody will be able to implement it. Okay. Now things are a little bit different now because we have relatively easier access to languages that are higher level and we have these wonderful libraries. But still, we want to make sure that, sorry for the patronizing analogy here, but we want to make sure that we come up with some sort of draft standard that isn't so great that it defeats principles like we're trying to increase interoperability and we're trying to make it easier for people to write clients. We don't want a lot of options, for example, in a draft standard. Options generally fight interoperability, not enhance it, which is a little different because usually when you're thinking about user software, you try to give them more things they can possibly do. Well, anyways, that's a personal opinion, by the way. Not everybody will agree with that opinion about interoperability, but there you go. So another thing that we talked about in the the abstract or whatever it is actually that introduced this session was we were going to form a cluster. And I asked Mark Parsons, I said, is a cluster really the right thing? Like, are we really going to meet once a month and have a speaker? And he said, clusters, you don't have to do that. We can do whatever we want. But I think if we're going to come up with a document based on these discussions, we want we want a short time frame. We want a focus that's narrow, not broad. We can make it broader later, but we want it to be narrow at the beginning because we want to succeed. We want to bring something to the in-person meeting in 6 months that is fairly tangible so that when this group reconvenes and it brings in more people and they say, I don't really have much experience with these, we'll have this thing and it will be, well, this document explains what we mean by a chunk manifest. We literally do want a chunk manifesto. We have to give my wife credit, though. She demands credit. She says she wants that. Um, and sometimes she comes to the ESIP meeting, so she might be there to check up on us. Depends on where it is. So we could form a cluster, but we'll need to structure it to suit our needs. And I don't think that having a succession of speakers is going to help us. It's going to be more like we're meeting to tag up. And we will need to break down how we handle the writing. It's pretty clear that there's a lot of things that we considered as potential chunk manifests or things that may help contribute to the definition of a chunk manifest. And we'll need to distill the information out of those. And again, like I said, the center column we have here is probably a pretty good start on that. But it's actually the way we deal with the things on the sides that's probably going to determine success. Again, not everybody may agree with that. So are there people here that are willing to be part of a cluster to say, yeah, okay, I'll do this and come up with the structure? I think it will be something like we meet once every 2 weeks and we use like Google Docs or something like that to organize our ideas. I have to admit it's rather daunting because a 6 month time frame is very short for this kind of document, I think. But if we take the word draft pretty literally, then it's possible. And Mark Parsons has his hand raised.
Yeah, I just wanted to this is great. I'm glad there's enthusiasm, and I love the Tiger team short focus aspect. Given that, because there is sort of a cluster approval process, and I'm sorry I don't know all the details, but I think regardless, you should just act as if you succeeded and proceed. But in that context, it might make sense to do it under the auspices of another cluster, a sub team within that cluster, just to throw that out. So.
I thought that as myself. I thought, wouldn't it be wonderful if somebody else actually did the organization of the cluster for us?
No, that doesn't mean that.
Oh, it does. Oh, darn. Okay, but you think that there might be another cluster. Do you have one in mind?
There's Amy?
I'm sorry, could you repeat the question?
You have a cluster, right, on cloud things?
Oh, yes. Yes.
Would this fit within sort of like as a sub team under your cluster?
Oh, yeah, absolutely. We've been a little bit dormant, so I would be happy for us to collaborate on having sort of, are you thinking sort of like a initiative under the cloud computing cluster? Yeah.
Yeah.
I would be happy to help coordinate.
Oh,
so that'd
great.
That'd be a great fit. So then you're like already in the schedule. And like Amy said, they've been looking to sort of reinvigorate, and clusters do this all the, they change their focus. So yeah, I think that'd be the easiest way to go about it.
I think that's fantastic. Chris, you have your hand up.
Yeah, I think also maybe at some point down the line, we do our IT&I committee once a month. But if you wanted to throw like the rough draft before the July meeting and get some community feedback, we've got space to do that as well. So just let me know.
Oh, cool.
Yeah, and I just want to double down on that because and thanks for that, Chris. Because we're trying to look at the committees as having sort of a more overarching view of all the different clusters, many different collaboration areas, and so sort of keeping IT&I informed is a great idea, and also helps broaden the reach beyond just the sort of cloud knowledge.
Sure. So can you remind us, Mark, what the difference is between a cluster and a committee? Sounds like a plan.
That question comes up a lot. It affects our governance. So we have administrative committees, like our finance committee and our governance committee. They are related to the running of the organization. They explicitly have the chairs of them explicitly have a role on our board. The technical committees like IT&I or data stewardship, I think it was just an artifact of history. It just became recognized that there was a lot of activity in this space and that they deserved sort of a bit more formality. At one point, they were eligible to get a little bit of money, like to bring a speaker to a in-person meeting, and the chairs of that participate in what is called the program committee, and which is what we're working to make it is more of something that has a broader view across all of ESIP. And so they're responsible for reviewing new clusters. They're responsible for bringing the sort of technical expertise up to the board. So it's a fuzzy distinction, but it affects how ESIP runs basically.
Okay. Okay. Yeah. I think those committees actually didn't ESIP the members at large vote on that, or there was some voting thing that happened a long time ago with the semantic committee.
Yeah, and the chairs are elected by the partners, and I'm not sure about the technical committees, but certainly the administrative committees are supposed to have a distribution of different types. We have these different partner types. It's getting into the weeds about ESIP structure.
Right. Gotcha. Okay. There was one question in chat from Jarrett. How does one participate in this cluster effort after the conference is over? And the answer is you volunteer. You just say, "Yep, I'm gonna do it," and then you've sold your soul.
You can also join the Cloud Computing Cluster email list, but better than that, I think, would be the Cloud Computing Cluster Slack channel, unless we want that's a good question, actually. Do we want a separate Slack channel for this initiative?
I don't know. We might want to have people join the Cloud Computing Slack channel all the same. And then we might want to have a separate Slack channel just for this initiative, just because we might want that. I don't really know. It's a tough call. But I mean, in the end, a Slack channel, if everyone winds up ignoring it, it's no worries, right? It doesn't cost anything. So we have 4 minutes left. Anyone else?
I just threw a link in the chat that shows you how to sign up for the Slack channels, subscribe to the community calendar, which shows when these things are happening. That's
right. And Erika?
Yeah, everybody, if you have put your email on the sign-up sheet on the first few slides, then we can also send up a follow-up email with an update just saying what we decided to do in the end and where you should find us again.